Okay, good. Hey. So I'm this guy. Anyway, I work in the Stockholm office. I've been doing a lot of sort of large productions for a bunch of years, and well, I'm sort of trying to bring ideas from very many $1 million companies to the sort of projects that Unity should be able to do, and is going to do in the future. That have to do with a bigger scale and a number of other features, right? So, yeah. Dear visual quality, we've been talking a lot about these features. I mean, if you saw the keynote yesterday, there was a lot about, we've been introducing 2D and new animation stuff and occlusion, and there was a mention of like shader lab features. So that was great, but it's not that we have forgotten about visual quality. I mean, right now we have a number of issues in Unity, like the default setup that you have for a lot of these, first object that is thrown in a scene is not necessarily the most beautiful thing that you can get. So we're going to be working on that. We're going to be working on actually making things pretty easy by default. Yeah. Let's see what we have here. So we've been taking a look at how difficult it is to make something that looks really good in Unity, as in what kind of data you need to coordinate to make your lighting work, to make your environments fit, your objects fit together, your shadows, and all that sort of thing, right? We have figured out that it's really hard. I mean, you sit there, you add an object, and you need to make sure that it has, ambient probes, and those probes need to be generated, so you need to place them, but if you place them and you don't have any static objects in the scene, you won't be able to make light maps, and the light maps you need for the static probes, which the whole thing is a bit strange. So we have sort of decided that we wanted to streamline the whole thing. We have also done the thing that is very logical to do, but maybe we haven't thought about it too much, which is that you have an artist that sits in front of Unity for the first time, and they're going to try to get something really good in screen. And the first thing that they do is that they go there and they try to figure out which shader they're going to use, right? And it can be very confusing for them. I mean, I've had people asking me, dude, what is the specular, diffuse, non-lit, bumped, whatever? And it's like, well, I don't know, but I sort of know, but you shouldn't be thinking on those terms. I mean, this is basically the math that is going to be applied, so your object appears cool in the screen. Like the fact that you have to choose the right kind of math is a bit counterintuitive, right? There's too many manual steps in general. I mean, you have to choose your shader, you have to enable this thing, and then you have to add something else. You have to set up your skybox, and your skybox doesn't really connect with your rest of your environment. You have to go to your light map settings and connect everything together. It's a bit, improvable, right? So we've been thinking about this, which is what focus we have now. What exactly is that we want to achieve? I mean, Unity is doing a lot of things, and in the field of visual quality, we can do things that are better. But the things that we need is not only that you're going to have something that is actually prettier in screen, it should be something that is easier to do. The artist should have less thinking time, as in, it should be fluid. Today it's not. Today there's a lot of hacking shaders together, spending a lot of time in Google and trying to figure out, what part of this, say, surface shader enables my wall space lighting instead of tangent space lighting, which means that I have to be including some vertex thingy. It's like, these things work, and they work well, and they have done a great job for a very long time. But if we want to make it accessible for everybody to increase the visual quality, it has to flow better than it has so far. We talk a lot in Unity about this idea of democratizing game development. Let's democratize beauty, right? Artists are really interesting, actually. There is a thing that is really cool with them. Their vocabulary don't really match the vocabulary that we have as engineers. I've had artists doing things like asking me for more contrast in their objects, Why are you painting this diffuse map? Oh, because I need more contrast. Well, you have this button here in the monitor. You can change the contrast around. No, I don't mean that. The black is not black. The black is not black because you have ambient, so you lower the ambient. Oh, now it's too dark. Okay, you mean something else, right? There's a whole vocabulary thing that we need to simplify. Right now there's a little bit too much complexity on the sort of terminology that we exchange one with the other. And hopefully this is going to have to do with, it's going to be partially solved by the stuff we've been doing anyway, right? Artists want to have Fresnel, and of course they want to have it. And yeah, they don't want to be looking for shaders. They don't want to figure out, like if an artist sets up a material and he needs one more option in the material, a normal map or whatever, he needs to figure out which is the other shader that is in this welcome to Windows 95 search menu thing that has exactly the same thing that he has, but it has a normal map. I mean, those things are not necessarily trivial at all, right? And then there's a thing about performance as well. Like we would like to be able to give everybody a bit of a hint on what are the costs of what you're doing right now, which Unity doesn't really have in any usable way. So yeah, the shader. I mean, in order to get to this situation where we can improve all these different aspects and actually make it easier for people to generate pretty things, one of the first steps, or the first step that we've chosen to take, is to improve shading, as in, let's get all these features in place. I mean, we're talking about pixel ambient and energy conservative and all these things, right? What is really cool about these things is that first, they bring up the baseline of what is available in Unity by default, always. And the second thing is that it sort of holds us responsible for a lot of framework that needs to exist around there. The framework today works, but it's very manual. So the team in Stockholm and part of the team in Copenhagen, we're actually going to be working into making these things a lot more fluid for everybody. So we don't have to make a demonstration or how well you can do something in Unity. Hopefully you guys are going to be able to just do something that is great, like by default, right? And then, all these things, of course, are a result of this law that says that the power increases every I don't know how many months. I think it's the Moore law, if I'm saying it correctly. Yeah, it is. So yeah, hopefully we're going to get a lot of these things now. I mean, we also know that mobile is gathering power, and I mean, we want to be ahead of the curve in what is going on, right? And so far, we haven't really been there, right? So under the hood, how does it look like? So the shader that we use is a very simple, actually single shader. One of the things that is magic, and it's going to take, if you guys haven't worked with this thing before, it's going to take a while until it's very clear how many side effects are derived of this thing. But the shader basically represents, it's a piece of code that represents sort of the maximum ability that your material has, right? And your material can be, say, an architectural material. That's, of course, one of the things about it, right? If you have all the possibilities of a material, so disregarding channels and data and stuff like that, if you have all of them put together in a single shader, then it becomes sort of easier to present this to an artist viewpoint, because you're not talking about a diffuse specular cube map something shader. You're talking about an architectural shader that offers you these slots. And the artist has what? 4 shaders to choose from. Architectural and some weird stuff that you use for car paint and skin and I don't know, something for the hair. Stuff that they really can understand and can jump into it. I've used that sort of thing in large productions, and it actually works really well. They don't really think twice about this sort of thing. They think about the data they're showing to the shader, not about which is the shader that will be receiving the data. So the first thing about it is that we have, I don't know how much of that I'm going to be able to show you today, but we have this, it's basically based on an inspector that what it does is it figures out which data you have enabled within the actual, material inspector actually, and that sets up a different shader permutation to be set up, so that if your channel does not exist, then that disappears from the logic, from the runtime, from everywhere. Adding a normal map is not choosing anything at all. It's that you have this one shader and you add a normal map, and then your cost and your look changes. You remove the normal map and you have exactly the same interface, but with different costs and different looks. You don't have to go around trying to guess out where you find the next thing, right? These things are very, very simple, but it has very deep connotations. I'll get to a couple of them later. Of course, the fact that we're talking about shader permutations brings the issue of, the compilation, right? Aras and the guys in Copenhagen that have been doing really, really good job out of making our compilation faster. I don't have numbers, but it's actually much faster than what we have now. So hopefully we're not going to spend all that long waiting for, the bloody baseball, well, the ball going around, right? The lighting workflow is sort of interesting as well, because all this shading thing will require data to be pushed into it. We're going to be working a lot into new features we haven't had yet. We have ambient probes. We're going to make that more automatic than it is. And then we have everything that has to do with the specular cube maps, which are going to be generated as well for you. They're going to be driven as well for you. They're going to be linked to the skybox properly. There's a few things there that will happen magically, so you don't have to worry about them at all. Making something that is pretty in Unity is possible. There's so many amazingly looking games out there, but it's really hard to go that far. So what we're trying to do is to make everybody go there easier, at least so your prototype, so whatever you do, before you invest a lot of time and money into making this thing really, really great, actually looks awesome from the start. So you can play around with that instead of having to go full in to develop something that may or may not happen, right? Just work out on something at the beginning that allows you to show it with very little work, and it looks really, really great. And you can compare that with whatever is out there, hopefully. Anyway, that was one of the things mentioned by passing yesterday on the keynote. There was some mention to the shader lab changes regarding, it wasn't really permutations, but it was regarding something that had to do with compilation times. In Unity, I think it's 4.3, we actually can drive pretty much every single fixed function state from the shader, from material data. So it's actually really, really simple on top of that. Let me show you there. This is actually, it's as simple as it goes, really. We have a seed right value that is declared. These are the properties, right? It gets declared, it is a variable, and then at some point in your shader, well, when you declare your pass, you basically use it. I have this disabled right now. I know, it's a horrible thing to do. But the only reason why it's disabled is because I'm not using 4.3. I'm actually using a stock 4.2 0F or whatever it's called, actually. Let me get back to home. And then we're going to be adding something that has to do with cost estimations. We should be able to figure out within a scene what is being expensive within this scene. You should be able to select an object and have an idea of how much the features that you have enabled in this particular object are costing you. So you can actually plan for, again, for scale, right? What do we have here? Oh yeah, the implications of this thing. And they're actually kind of interesting. Of course, the artists are going to be happy because they have a single shader or whatever it is, right? And hopefully we can replace, because there's a set of shaders that exist today, hopefully we can replace all of them, even if they stay the same, so we are backward compatible. We should be able to replace them for something that has these data channels instead. But of course, in the general case, they hopefully are going to be browsing for shaders less. The second thing is kind of interesting. There's a little story that has to do with a project that we did in Stockholm as well. It was before I arrived, which is the butterfly effect. The butterfly effect, it was a very large production. And they had issues with the stuff like figuring out if the light maps made sense. They ended up adding something to Unity that allowed the editor to show only the light maps, right? And that's actually great. And they were talking about bringing it back to Unity. There's been a lot of discussion about what can be taken back from the butterfly effect into Unity. There's been a lot of effort in that sense. Because it was a sort of special version of Unity, 64 bits, because it was really, really large meshes and stuff like that. So one of the things that happened there is that they added this possibility of showing the light maps, right? And the showing the light maps thing didn't really make it back to Unity because we didn't think that it was, or they didn't think, I wasn't there, as I said, that it was elegant enough. And I have to agree with that. I mean, when you're going to show a line map or a normal map, a spec map, I don't care what it is, right? You're not really, you don't really want to show the map itself. You want to extract some kind of information from the data that you show, right? Let's say that you're showing all the normal maps. You probably don't want to show just the normal map. You want to take the normal map, you want to normalize it, you want to take those numbers away, and you want to multiply that as a factor. So if you can see if any part of your art has non-normalized normal maps, right? Like whatever it is. if you have a single shader, if you have a single place that is running, well, 90% of your scene, any change that you do in any part of that shader is going to affect your whole scene. If you want to show how your specular red channel is compared by the blue channel of your diffuse and multiply that times something else, you can do that. You can do that in a single place, and you're having access to everywhere. You're having access to the whole scene with this change on. If it's important for you, you go, you create a variable, you link it to the action inspector, and basically you enable and disable with a click. You don't have to customize sort of the Unity experience itself. You can do whatever it is that you need with the shader you're working with because it controls enough of your scene to be relevant. If you're doing this in a skin, you're probably going to want to extract different information from it. So it actually plays very well in a bunch of ways. That's sort of related with the next one. Like one thing that you can see a lot in large productions is they have this idea when you have a shader that has many channels and the object does not require as much detail because it's far away, because it's lower than hardware, hardware, whatever it is. One of the things that you do is you start deprecating these channels, right? This deprecation, you can set it up so it's as smooth as possible. So you take an object, you move the object away, and this normal map sort of can fade out. And the moment that it fades out, you can actually remove the normal map being sent to the GPU, which can disable per pixel lighting and doing so on and so forth. You control within the shader how the shaders become other shaders. Today in Unity, as you all guys know, we have this fallback thing. That basically means that if you're not going to run this thing, you can actually run the next version of it. That may or may not make sense in all cases. There are situations where, for instance, you could be modifying, say, the way that your vertices are placed or whatever it is, something that if you decide that you're going to use a fallback shader to do your shadows, which is a classical way that Unity uses, your shadows may actually have a different behavior in terms of vertices if you do something custom yourself. This sort of approach solves that. You disable whatever it is that you want, and you keep what is relevant for the kind of rendering that you're going to be doing. And of course, the fact that we don't have to have different versions of the shader for render states and so on and so forth makes it possible to have a more self-contained shader code. In the case of the shader that I have today, which is going to be available public and it's going to be included in Unity and all that, in the case of that one, it's a single file. It's the file that I saw before, and it's not even all that big. And yeah, and it can be made smaller, actually. Yeah, mobile. Thing is this, right? Visual quality is great, and we really care about it, and we really think that if we have a framework that makes sense, that has an easy workflow, we should be able to, or rather, we have to get that one right before we can start thinking in other things, right? But we know that Unity has a mobile heart. So we are working already on getting some of these, or all of these features adapted to mobile as well as possible. The idea is that this is going to be available across the board. Hopefully, the fact that you also have a single shader is going to make it easy to fall down to a certain level of performance for the platform that you care about, right? Yeah, other things that are missing there are stuff like HDR support and all that, but I don't really know how well that's going to play with mobile. Some things can be baked, like for instance, BRDFs. The BRDF that we're using right now can be baked into a texture. We know that that is faster. You have seen the video of the chase, I guess, before. That comes from the Stockholm studio as well. And that one does have this idea of looking at BRDFs and textures and all that. It actually works better in mobile than anything else. But you probably already know that. Yeah. Demo time. Let's see what it looks like. So this is it's kind of a strange demo, really, because it doesn't have all that much life and all that to it. But it works like this. Designing the Ubershader, one of the things that we wanted to make sure is that we had not only something that made sense from the technology viewpoint, but something that made sense from the art viewpoint. So we hired a couple of really good artists that were working with us, and we were working with their tools as well. Like, even if you have a revolutionary new way of doing graphics that blah, 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 you will still need to push data into that. And we wanted to make sure that we are compatible with the data that we have today, but we are not cutting any roads for the data that we're going to have tomorrow. So we were working with this guy, and we got a few things built, and they work really well. And at the end, we agreed on a pipeline. It's like, okay, it's going to look like this. We're going to have these channels and blah, 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 blah. And then this thing that you have there, it actually was built in 4 days. Single shader absolutely everywhere. He actually found it a bit boring that you just have to create one more material with the same shader and change the data around. It's like, can't you just have the material by default? It's like, no, let's let people choose their own shader. That is a red ball, mostly. It actually has the stuff that you could imagine. I mean, it's your simple Fresnel plasticky object and and all that. But if we go and we select it, for some reason I think it's called Chrome Sphere. That's awesome. Yeah, thank you very much. Well, we have the classical thing, right? I mean, this is the. Let me choose an alpha. I think I have something here. I have a texture here that has the. Yeah, there you go. So yeah, you can do things like. Well, that's because we don't have alpha test ref enable. We enable it, and there we go. It's actually very simple. This is just an inspector that is sending the right data down to the shader and so on and so forth. The stuff like normal maps and all that, I mean, they just, that shader right now is really, really cheap. We choose a normal map, and the shader is not as cheap, and the normal map is doing what you could expect, and so on and so forth. You have an indication that it's too expensive, and you want to remove the normal map is removed, and then everything else happens the way that it should happen, right? We just have, a lot of features. We have, for instance, the scale of the normal map. We can play with that. That's very nice if you want to take away objects that have normal maps. You want to fall back. You can just scale down the normal map and then just switch them out, and it will work. It's not going to be visible. You can control the glossiness that the object has. The glossiness indirectly controls the Fresnel. So we don't really have a Fresnel map, but it works really, really well. Like, the artists were happy with that, and they were asking for Fresnel like there was no tomorrow. And then we have an occlusion map and so on and so forth. And then we have a screen that is going to give me trouble, actually, because the play button is not there. Yeah. Just die. It's actually not as simple as you can imagine. So this is running on, yeah. You can see it, yeah. So that's actually built after 4 days. I kid you not. We're very, very happy with it. We use some tools we actually got a SkyShop, which is pretty bloody good tool. And we use that to generate our, the actual data that we send to this thing, like they do all the convolution and all that. We just plugged it in. So you're going to have a few environments. Some of them are, yeah. Yeah, basically, your lighting, that's what you could expect. This runs, by the way, really, really well on Intel integrated as well. So it shouldn't be that far from being able to have this in mobile. We have some, yeah, interesting art. It's a really cool character. I still haven't figured out where it comes from. This needs like some music or something. Oh. Are we done? No, we will not. That's not a nice shadow. Ah. Seeing a guy building this in 4 days is really scary, actually. Yeah. So, yeah. This is going to be released. It doesn't support all the features we're going to need, like some of the lighting framework is missing and stuff like that, but the demo itself with the shader and the custom inspectors and all that work is actually going to be released it's going to be in about a month. Basically, we need to pack it up, clean it, and make sure that it's nice. The new lighting support is going to be in a nearby version of Unity, whatever that means. I mean, we work, so we tend to put a lot of stuff together, but it does take a while just to make sure that it works in all cases. And defer lighting is going to take longer. So I don't know when that's going to be. We probably will have this around, and then if there is a clear need of defer, we will work on the defer thing. It's not something that we have ruled out at all, but it will probably take a bit longer, right? And that's about it. So questions?